Okay, so we're going to use the ratio test. So remember, here's important. You must write the limit as n approaches infinity. Okay? This could be and probably will be a free response question. So if you do not write the limit as n approaches infinity, you're already starting off in the negative. Also, because we're taking the absolute value of this, I can ignore this negative 1 to the n. What is this negative 1 to the n doing? It's causing it to do what? Alternate. Okay? So because this is causing it to alternate and I'm taking the absolute value, I can ignore it when I'm doing the ratio test. So I'm going to write this as x to the what? N plus 1 over n plus 1. And then I'm going to divide that by the original sequence, which is going to be the same as multiplying by the reciprocal. And I want this to be less than 1. You all with me? Okay. What is this limit? Well, let's rewrite this a little bit. Can we just rewrite this just a tad? And I can write this as x to the n times x to the first power. All right, if I take the limit as n approaches infinity, what happens? X to the n cancels. What else? N over n plus 1 cancels. Does everybody understand why those cancel? Yeah. So I'm left with the absolute value of x to the n is less than 1. Picky, picky, picky. Okay, just x. All right, so now how do I rewrite this? Negative 1 is less than x is less than 1. From here, I can tell my radius of conversion. What is my radius of conversion? What's my radius of conversion? 1. Okay. Now I need to check my endpoints. On the test, don't make me look for where you're doing this. So I want you to do it nice and neat. I'm going to show you how I want it. You want to say something like check endpoint negative 1. When I check the endpoint, I go back to the original expression and I have to consider the alternating part. So when I check this endpoint at negative 1, I have negative 1 to the nth times negative 1 to the nth. That's because I'm substituting negative 1 in for x. Is everybody with me? Over n. Now I have to use the rules that we learned in last unit to determine whether or not this converge or diverge. Well, what's negative 1 to the nth over negative 1 to the nth? What is that? Or not?
Or that.
When they have the same exponent, when I'm multiplying something with the same exponent, I can multiply the bases and leave the exponents alone. That's what you were thinking. All right, does everybody understand that? Will this converge or diverge? Diverge or converge? Diverge or converge? You're just changing your answer because I didn't like the first one? Why does it diverge, Noah? That's what you want. I want you to write on the AP exam because this is one of those stupid thingies. So, why does 1 to the nth over n diverge? You think it diverges or converges? Which one? Why does it diverge? It's a p-series. It's just 1 over n. It's a p-series. So this diverges by p-series. That's that thingy. Alrighty. Now, we need to check the endpoint at 1. Remember, on your test, I want you to write this down. Don't have me looking all over your test for where you check the endpoints. So I got things to do. All right, so now I'm going to put 1 in for x. So I have -1 to the nth times 1 to the nth over n. Converge or diverge? Diverge? Why diverge? Diverge or converge? Yes, and even though it converges conditionally, it still converges by the alternating series test. Are we good on that?
Yeah.
So when I ask you for the interval of convergence, the way you would respond to that is parenthesis -1, 1, bracket, because that 1 is included. It will converge at 1. Yes?
So, I never really thought of asking this, but why would we want to know whether it's conditional convergence or absolute convergence?
That's just a question that they like to ask on the AP exam.
There's no, like, meaning.
No, there's no meaning. Just a question they like to ask on the AP exam. Yes?
When we multiplied -1 to the n times -1 to the n, so we just leave the exponent alone and just multiply the two?
Yes. When we multiply -1 to the, if the exponents are the same, we multiply the bases. Yes.
So we similarly said that if the bases are the same, we could add the exponents and the, like, -1 whole squared, because it would be -1 to the 2n, and it'd say -1 whole squared is 1.
No.
Why not?
That works for -1. It does not work for all values.
Yeah, but just in this case, it would work.
Well, it's bad math. So no, we don't do that.
Okay.
Even though it works in this case, it's still bad math. We wouldn't do that.
I thought that one of the exponent rules was that when you have two bases that are the same, you multiply them together, that you can add the exponents.
Okay, so the question is about exponents, okay? So if I have, let's say, 6 to the 3rd power, that's the same as saying 2 to the 3rd power times 3 to the 3rd power.
No, that's saying 6 to the 2nd power times 6 to the
No,
3rd power.
that's the same as 2 to the 3rd times 3 to the 3rd.
That's not what I said.
Take your calculator out, let's figure it out. This is 8 times 27, and this is 216. Are those the same? It's the same. Okay, so if the base, I can take this exponent and write it this base this way, right?
Should we also
What-
say 6 to the 1st power and then 6 to the 2nd power?
So you're saying, is it the same as saying what?
6 to the 1st power and 6 to the 2nd power.
It is.
So, in the case I was talking about, where -1 to the n power, we could say -1 to the 2n power. Because -1 to the n power plus -1 to the n power.
No.
And n.
So you're saying, is it always -1 to the nth times -1 to the nth is -1 to the 2nth because you're adding the exponents?
Yes.
Does that always work?
Because that one will be possible.
I think that only works if the bases are the same.
The base are the same, I think.
I know, but what I'm saying is that our bases may not always be the same here. So what I'm trying to get at is that these bases are not the same here. But I can add, but the exponents are the same.
So would you only give them?
So that's how I was breaking that up. I was not breaking it up using this rule or using this rule. So I'm not using this rule to do it. I'm using this rule.
Will there be a case on any of our exams where we have to use that rule?
This one, the 2 to the n?
Yes.
Maybe.
Okay.
But this is the rule I was using to do that. Okay? All righty. Any other questions? All righty, I want you to do this problem.